will it actually happen? Oh, right, we've got the chat room up, we've got everything. Good, right. Let's say hello to everyone. Hello. Ah, bless. The beauty of life. Where's my chat room? Here it is. There you go, that gives you a start time, I guess. There we are. C, we're doing C. This is day 2. Day 2, eh? We're in code. So how far have we got? Quite far, to be honest with you. Let's try it. Yeah, not doing bad at all. We've got a window and a red square. Oh, lovely. Using OpenGL version 3.3 on NVIDIA 440 driver. Okay. I'm happy with that. Are you happy with that? That's the big question. I've done a code review. And I'm happy. I've looked at this glue and decided I'm going to keep it in. It's not doing much at the moment, let's put it that way. But look at our main file now. This is the biggie. This is the biggie. Look at our main file now, eh? It's getting a little bit stretched out. You can tell I started putting these in so I can locate things. As soon as I start doing that, you know it needs a refactor. And I think at the beginning of each day, I do a code review, usually in the mornings, before I come on stream, just to make sure that my code is correctly put together. This morning I went through an email sent in to me yesterday by one of our subscribers, by one of the subscribers to the channel, or followers of the channel. He's not a subscriber, sorry. You can subscribe if you want, that's up to you. But one of the followers of the channel sent me an email saying how to do the library in a different way, using extern C to stop the mangling of the names, which is what happens in C++. Can't do it because it's a static library. I forgot to say that it's a static library. It'll work on a .dll or something like that. But at this point, I don't want to do that because that means moving your library around and messing about. A static library compiles into main, which is why we're getting such large code base. That, and we are now in debug mode. Did I put this into debug mode? Yes, I did. Yep, so we'd have to change over to release to get our file sizes back down, I think. But anyway, that's not a problem. I want to be in debug mode so I can place little dots on here and say, oh, stop, stop. But all this code works. And I've been through it with my little dots this morning. I didn't want to bother you lot with that. So let's get this microphone into the right place. Excuse the microphone. Ah, that's better. Relax. Stretch. Ooh, stretch. And let's start looking at this code. We need to refactor. There's no two ways about that. So how I do my refactor is by looking at the main event loop. What do we need? We need those two variables, running and event. So those two can stay. And we need a window. The window actually holds our context at this point, doesn't it? Yes, it does. So I don't have to mess around with this anymore. So everything can go into a file. So let's set up the file. What should we call it? It's got to give us a window. That's one thing that we know. So let's have a window. What are we going to call it? Let's call it one sec. I want to keep... Yeah, we're using capitals. Okay. I want to keep the casing the same. So create underscore window 3D. How about that? Then we'll take in some variables, which we'll decide in a second. And then we'll do that. So, I've also changed the beginning, by the way, on the code review. So argc and argv are back, we're just not going to be using them. So everything from 41 hold on a minute. No, everything from 47. Here. Welcome to the sandbox isn't really anything to do with the window. But all of this rubbish is up to there. I'm going to cut. And I'm going to paste. Lovely. All we need at the bottom here is now return window. There we go. Can't have a 99. We can have don't want null pointer or null. Well, we've been using null so far, haven't we? So let's go with null. May as well, because that's what we're detecting. That's okay. Any more errors here? Oh, got return 1. So null. I get rid of you. Okay, we're not calling it yet, so that's fine. Let's have a look at the top. No, that's okay. Okay. That's not very generic. That's only going to give us whatever we put in this file. So to me that is good, but not that good. So what we do here is SDL underscore window. No. Whatever. Yeah, SDL window. Window. We'll still call it window, it doesn't matter what we call it here. Equals create window 3D. Okay. That makes the program work. Let's check if that makes the program work. Yes, exactly the same as we had before. We just get a red window. So we've refactored so far. This isn't very generic. We're only going to be able to create a window, and we are being told what we're going to receive. We would like more control over our window. What would we like to control? Its size, maybe, and the title? What title have we got so far? So, yeah. Size of the window, definitely. Title, an SDL2 window. That's not going to cut the hatchet. Yeah, we can change that. So that'll be okay. Let's so what I'm going to do here is I'm going to make sure it's after our thingy up there. So hash define window title, and what we're going to make that is a a const char star what we got here, sandbox for C OpenGL. That looks okay. Hash define actually I don't need the const char star. Yeah, I can just do that. Window width we shall make 900. Oops, what did that do? Page up. Okay. Didn't have my num lock on, did I? Can we get rid of this? Okay. Doobie doobie doop doop. And come on, keyboard, you can keep going. I'll put new batteries in you now. 900. And hash define window HEIGHT 500 we're having at the moment. Sandbox for C OpenGL. Yeah. What I want to be able to do is put in here title. Well, let's show it, shall we? I want to be able to put in window title, comma, window width, comma, window height, which has disappeared on me. Window H. And that's why. helps if that's correct. And window. Height, there we go. And we get red squigglies. Why? Because this doesn't take them. So we're going to need those 3 items coming in to our 3D thing here. So we'll have a const char star title, an int width, and an int height. That will work. So here we can just put title, width, and of course height. That looks good. F5. There you go. We have refactored correctly. Good. Everything works. Is there anything else we want to control about this window? So we've now got... Oh, I didn't even look, because I'm an idiot. Yeah, sandbox for C, OpenGL. So there we go. We've even got our title going now. So it has changed. It's improved. Step forward. Window null. No, don't care about that. Setting these attributes. No, I'm not going to mess with those. Context we don't care about. Glue we don't care about. Got a printf in here. I think that's good to have. No, I'm happy with that. I don't think there's anything else I really want. I was thinking about maybe the OpenGL version. Maybe. But is that really worth it? Oh. Am I allowed to do that? Alright, I just need it to come down about another 100. How's about that? It's in pixels. Yeah, that's better. That makes it, I don't have to keep dragging it over then. God, I'm lazy. There we go. That's better. That looks like a very useful create window 3D. If you want my opinion, but nobody usually does, so my opinion is invalid. Where are we going to put this? We are going to put this into an initialization file. Okay, so let's put it into some kind of initialization file. New file, and we will call it sand init. Yeah, I want it in the top. So I want sand init. There we go. Yeah. Yeah, that'll do. Alright, so the initialization file will be the same as this one. We are going to alter that to sand init underscore h. Not sure how many of these I'm going to need. I don't need a lib. Or do I? Right, best way of doing that is just doing that. Okay. What we do need though, from main, is whatever we're using, which is you lot. Do we cut? No, we copy. These are ones that I do know we need. So actually those should come before. Okay. And that signature, that's called a signature, that. So we'll copy you. And we'll have you in it. That replaces you, and we have to have a semicolon at the end. That's the signature. There we go. That's better. Let's tidy this signature up. There we go. So that's the signature. That's all good. We are on the 12th. The other thing I'm not doing is I'm not namespacing this lot in sand. That's awkward. So I'm going to start namespacing, I don't care. I think it's a C++ thing, but I'm going to do it anyway. Alt Shift, bring down, tab. Yeah, I think I'm going to do it that way. I haven't introduced namespacing so far, but what it does is it protects our code from interference from the outside, from our main program and from all of these libraries. That might be a good idea. I think I'm going to do the same on here as well. Namespace, sand. There we go. That's better. That looks better. Right, that's readable. So that now has done that one. That's correct now. Good. Now we need to do the CPP file. So let's correct our first CPP file first. So namespace, sand. Keep everything in the same namespace here. And all we have to do is close it, don't we? There. So everything from here, Alt Shift. Nope, missed. All of this lot. Just tab it in. That's it. That's lovely. That reads okay. Lovely. That's okay then. Copy that over. Hash include and inverted commas sand in it. Sand in it.h. Thank you. Namespace sand. And we can put our function in here. So let's do that. Here's our function. Cut. And paste. Has it indented everything properly? It has, but we're having problems now with SDL window. No, we're not. Everything works. That's with. Hold on a minute. But we've got printfs and stuff in here. This isn't going to work, is it? No, is it hackers like? It's just stupidity, I think. And it's been double stupid. I see. Is that okay to leave it as it is then? Because that's on the wrong line. No, it's not. Damn you. Damn you, damn you, damn you, Windows. It's because it's there. Hello, Muppet. So let's grab all of you lot. And just tab you in. That's now correct. Yeah, that's correct. That file is now correct. So let's add it. Okay. Sand slash sand init dot h. Good point. We need that thingy on, don't we? Sand stroke sand init dot cpp. Yeah, I'm using CPP files because I'm being lazy. There we go. That works. That's the pro done. Nearly. Don't forget our libs. Yeah, I'll put them here. I can take that lot out. We're not using Qt. Clean it up. Looks good. Right. Sandbox lib is up to date. Sandbox sandinit isn't complaining. Oof, it should be. Main save, and we need to use it. What I'm going to do is I'm just going to cut you out of there. Put you together, and we'll hash include sand slash that init. That will take care of this file, I hope. Maybe one day. It's not undefined at all. It's here. It's here. Create window. Yes, it will still be undefined. I just realised we haven't compiled our sandbox. So let's try compiling our sandbox. I'm going to get all of this lot out of the way because oh, wait a minute. I have made one mistake. Oh my god, I've made one mistake. It's not the 11th. It's the 12th. There we go. Right, let's see what messes up, shall we? Nothing. How did it do that? Okay, I'm not going to argue. I'm not sure. I'll tell you why I'm not sure, why I understand that in a minute. That shouldn't have worked. Make sure our main file's okay. Terminal. It can't pick up create window. You're quite right, it wasn't declared in this scope. It's declared in that scope though. So yes, as you can now see, we have to put sand in front of it to use it. That protects it from all of the variables that we've got floating around in here, to be quite honest with you. Probably except for the defines, which don't matter. Okay, let's build our sandbox. It seems to be working. Let's try running it. Oh look, it's working. And it shouldn't be. The reason I'm saying it shouldn't be is because of that line there. That command, printf, is not anywhere within here. It's in stdio.h and I've commented it out. So to be precise, we should uncomment that. We don't need that lib. Okay. That's fine. What I would prefer to do though is have that break there, that break there. Lovely. Just so I know where the libs have come from, or what libs are what. Those are external dependencies, and that's from the standard library. It might look obvious, but when you've got them in a big list, it doesn't. Nice. So that's the only alteration I'd make there. I don't trust what it's doing. It's actually picking up standard stdio from here. And it's using it within here to allow it to run. So if I was to put that first, it wouldn't have run. If I was to put that there, if I was to put line 30 on line 22, it would have crashed or not compiled. So I've put that stdio in there just to make sure it'll compile, no matter where you put it. stdio.h, by the way, only gets placed once. It's got header guards on it, so it doesn't matter how many times you repeat that, it'll only be added to the program once. So in fact, we should have that in the standard header area. So I'll put standard headers here. Clean up our file. We've now got some hash defines. Why am I using hash defines? It just makes it easier to find, well, to alter these things so we can play around with them. It also notifies anybody who sees the examples that they can play around, they can use them and play around with them like this. So that's our initialization now. Yeah. What I'll put here is C sand slash sand init.h. That's the only comment I can put there. Then we have our main event loop and everybody's happy. Okay. So we poll the events, update our game. Then we do our render game. Brings you across. and then we just swap buffers. There we go. Make that more readable. That's not clean up. That's XDL. We do need a cleanup. Right. We've now got a game loop. Do we want to do keyboard events? Not particularly yet. So does that fit on one screen? Yes, it does. The whole loop fits on one screen. This comes in later. End of main event loop. Excellent. I told you I write my games and stuff in English, so yeah, we're programming in C. Is that a good starting place? The file is still a bit big. All right. This main file is still bothering me. Do we refactor the main event loop at this point? Yes, we do, is the answer. But I want the main event loop to be in the same file as our main. So what I'm going to do is I'm going to forward declare that it's going to be here. It's going to return what? A bool. I don't know if it's worth doing. There's about 2 or 3 different ways to do this. It doesn't have to return anything if we keep that with it. So if it doesn't return anything, it just carries on until it finishes. Yeah, that would be damn sight better. Where do you want to go, Muppet? You want to go that way? Okay. God, you're hot. No, love, you've got to keep going. You can't just stop on the keyboard. No, I'll have a void, and we'll call it run. Run, and it will take in, well, it's going to have to take in the SDL window, isn't it? I think. Yeah. that. And we'll just call it window again because I can't. There we go. I'm just going to put semicolon this time. All I'm doing there is I'm telling the compiler that this function exists, and because we have to have all our functions written before main for them to be able to be used in main, it means that it will now call, it knows to look for that, but we're not going to be putting it up here. So this is the first time I've used this technique, which is interesting. Where we're going to put it is down here. I'll just put a line because I don't know what to put at this point. So I'm going to do that, that. We are going to take everything from here to the end of the while, to the end of the loop. Cut. Paste. There we go. That's how you run the program. And here we just put run window. There you go. So that's how we are able to write things below main. And I would prefer to do it that way, because that tells me what functions we've got coming up. Now, main itself should fit on one screen. And it does. Compile and run. There you go. It works. Awesome. I think we've refactored well there. I don't think I need line 53 anymore. I don't think I need that. We have a straight program, and that has to be separated off as I return. Things we haven't done is check our window. So if window is equal to, we're using null to be consistent, then return 99. Run window doesn't need any checks. That's it. That's our whole, that's our main. We're finished with main. That's it. Good time to commit. Okay. Refactor. And we have now got create window moved to sandbox lib and main loop moved to a separate run function. That's our refactor. Okay. Updated. For namespace sand. And we now can include sand in it. There we go. Done. Magic. Our sandbox lib now has 2 functions in it. It grows. It grows. Oh yes, this is a slightly better program now. Functions that I don't want in the lib are come here, so... There we go. There we go. Label that the main entry point. Yep. There we go. So I've now got it down to... We might do something with those. We don't know yet. We haven't decided upon anything. Welcome to the sandbox. Create a window. As long as it's open, run window. After it's finished, or when it returns, we can destroy the window. Yeah, that'll be fine actually, because it's all in the same file, isn't it? Due to hash includes. And SDL quit. Yeah, that'll work fine. There's no errors there. Because of the way C works, rather than anything else. Rather than by design. Yes, Muppet, what can I do for you? How are you doing? You want to come back up here? Okay, then come up. Come on then. Okay. Do you want to go on there? There's nobody there. Go on the windowsill. Have a look out the window. Come on. Come on. No, okay. Right. 5-minute break. Yep, we've been going an hour. So if you want to go and grab a cup of coffee, now you can go and grab a cup of coffee as Muppet decides to sit on my keyboard. No, Muppet. It's not a good idea. Let's just pop it there so it's not on a line. That's important in case you do sit on the keyboard again. Alright, well I'm pleased with that. That now looks like a program, and as you can see, it's starting to make sense. It doesn't look like C, does it? But it is. And this is how we're going to program. We're going to program by writing some a C function. Ah, there he goes. Knew it was going to happen. No, you're not sitting on here, love. Move. Thank you. Gosh, it's awkward doing this. He likes to be all over me, put it that way. Muppet's my cat, he looks after me. Because I can't move around a lot. And he always likes to make sure that I'm okay, but he's ill at the moment. But he hasn't been sneezing as much today, so far. So there is hope for us. Not to have a bath at the end of each session. Yeah. I like that. I think we can move on from here. So what game are we going to make? No idea. We should really decide on a game to make. Or shall we just do the basis for a game? So, what would we need to make a game? Right, so we've done that. What's next? What makes a game? And the answer to that is a scene. So, an interactive scene is basically all it is. That's all a game is. It's just a scene which you can see, something you can see on your monitor that you can interact with. So how do we make an interactive scene? Well, we're going to need some kind of graphics. So, so I can just type freely, I'll do that. GFX in OpenGL. Actually, special effects. Well, I haven't done those. In years. What can we have here? Textures, models, map, tiles. Don't know. It's just an idea. Shaders, special effects, shaders, physics, no, what physics. What can we have for physics? Gravity, collision, interaction, mouse, click, keyboard, what else can we have? Any more ideas? Come on, peeps. That was me dingling for being online. Well done! Well done, Twitch. Thank you for telling me that I'm online and I'm streaming. That's very kind of you. That means everybody else has now been told. So nobody knows up until this point in the video that I'm streaming. Oh, that's excellent. And they want to make money out of adverts. Tough. I'm not using them. I think we could make a map tile, and then we could make a player, and then we could do the physics, and then the interaction. I wouldn't mind doing the special effects first. Will we be using game states and things like that? I don't really see a need, as this is just going to be a sandbox. It's not going to be anything else. We might do later on. Game states aren't a hard thing to implement. All it is a stack where you stick the current game state on top. You either switch in and switch out, or you pop on and pop off. That's the only two actions you take on it, and your game state then follows its own rules, generic rules. So, are we going to start with 2D? Or, well, it'll still be an OpenGL. No, let's start with 2.5D. That really does have some excellent ideas in it. Yeah. That makes the interaction better. Do I want to include colours and textures, or just textures? No, I want to include colours and textures. Let's make life difficult for myself. Why not? We can do shaders already, because we already have a texture file utility, a text file utility. So that can cover shaders. Shall we play with shaders first? Shall we start with a classic triangle and get a shader working? The open world of GL. I wonder. Well, I think getting shaders working would be a good idea. If we can get those working at the beginning and get a colour model on screen and then do a textured model on screen. Do we do texture or colour first? Colour. then we will have, once you've got a textured model on screen and a colour model on screen at the same time, you've virtually cracked it. You cracked the graphics. That's literally all of the graphics. But that's a lot of work to do. There is something. I've missed a camera. Otherwise you're never going to see anything. Duh. What drinks have we got here? Okay, nothing on chat. Great. Fair enough. Right. What I'm thinking, that's going to get so complicated so quickly. Is to skip all the graphics for a minute and just get on with the game. So we'll do the open world example and we'll do it with colour. That will be next. Okay. Draw a coloured, spelled the American way, square on screen to represent the player. So that's the first time we've actually said the word player. Which we're not going to have. Right, we're going to need some maths. I'm not prepared to write a maths library again. Not today. There is already plenty of maths libraries out there, all ready for us. What can we have? Do we have graphics library maths? We do. C++ mathematics library for 3D software based on OpenGL shading language. That looks alright. It says C++, but GLM is written in C. I want to check that out. It has to be written in C. Okay. Where's GLM? Gone. Huh? Okay, C Maths Library. That's math.h. Nope. It's got time in there though, interestingly. Oh no, it hasn't. It's all here. Cos, max, min, greater than, less than, log, modular, power, sine, tangent, square root. No vectors. Double and float. Okay. No, we're going to need vectors. That just runs through them all. Not interested in the base one. Math.h. I want to extend that. There you go, GLM. Here we go. Let's have a look at this a bit more. Pop you over there. How big is this page? Wow. Pretty big. Okay. Okay, that's all we need. Right. OpenGL Mathematics is a header-only C++ mathematics library for graphics. Yeah. Class and functions there for implementation. C++. Is there not a C version of this? I don't think it really matters. It's a header only. And it does go with C++ 11. Sorry, yeah, C++ 11. We've got up to 20. Is there no other maths library? Is that the only one? CGLM. Really? Okay, I'm not going there. Let's try CGLM. Okay. Inline versions and parameters are documented inside the corresponding headers. Complete documentation, blah, blah, blah. It's CGLM. Here's the documentation. It is similar to the original GLM library, except this is mainly for C, obviously. Yeah, thanks for that. Okay. We don't have it. Okay. So we can't use it. Fantastic. Well, that went well. Okay. When was this last? Got an API documentation and a manual. That's good. Ah, didn't want that. April 13th, 2020. Right, we'll use it then. It's been updated. We'll use this version of it. Tough if it's... There is a C variant, but we don't have it accessible. So we'll use GLM instead. Manual. Okay. It's got a full manual, which I guess we could download. It's a PDF. Okay. Fair enough. I guess I'm going to add this to my Dubreeze. Okay. For God's sake. I just can't get a hold of the windows. Right. Licenses, good. Software, good. Getting started. Looks good. Oh, it's headers only. We don't need to put anything in our profile for that. That's perfectly okay. We've got those available to us. Now, there was something about GLM that it's not telling us here. A hash define, maybe. But pull a lot of code in. Yes, that's what I was just thinking. Because we need both. Damn. Okay. How bad is this going to get? Currently, I haven't been very careful so far, so I'm going to start being careful. We are in build directory. This is the debug version, so it's got all the debug symbols in and everything. And we're at 56k. Okay. Let's have a look. I can go with this lot. Hash include GLM. What's inside the folder? We've got GTC and GTX, so that's your extensions library. Which ones are they saying to use? EXT, okay. GLM.hpp and hash include GLM, and this is the EXTHPP. Okay, let's compile with that. Those two header files. Whether it's using them or not is irrelevant. It compiles okay because they're only headers, but we've only gone up to 57k, even in debug mode. Right, I'm okay with that then, so far. That will give us everything that we need. Which means I can now do something like GLM vec4. Yep, vec4, vec3. Alright, we'll get 3 different things we can do here. Can we just put floats in? Oh, we can just do vec3. Vertex equals, I would have thought it's something like GLM vec3 open brackets 0.0f comma 0.0f comma 0.0f, something like that. Is that correct? Yeah, it is. Is the answer. Right. Do that. That is still correct. We're on a winner. This is where I don't like this. And I prefer that. Okay. Right, so where should we put our first vertex? We can put that top left, which is a minus in the x direction. We'll only do 0.5. So x, by the way, you got the center of the screen, which is 0, 0, 0. We then have the y direction going up to 1, minus 1, 0, 1. X direction is minus 1, 0, plus 1. So in the x, I'll go halfway across the screen backwards. So halfway across the screen to the left. And we'll go halfway up the screen in the y direction. In the z direction, I'm going to leave the z's alone, shall we? Yeah. Just leave that alone. Does Control D work on this? I don't know. Doesn't look like it. We need 4. We need 4 points on the screen to draw a square. We don't need the last comma. So that's the top left. We have to note that OpenGL by default draws in a counterclockwise direction. So we want the bottom left, which will be the minus minus. Then we will want the bottom right, which will be a positive in the x direction. And positive in both directions will give us a top right. Lovely. Just label them so we know what, so we can call them something if necessary. This doesn't do anything for the program, it's just to remind me of which vertex is which, because I'm going to need that in a minute. Right. Let's have some colours. So GLM, Vec4. I'm not happy with these being Vec3s either. No, I'm not happy with that. Sorry. It's because it's wrong. That's correct. I'm not going to tell you why it's correct. I'm just going to say that's correct. If you do know why it's correct, then that's fine. If you don't know why it's correct, ask. Either in the comments on YouTube or come and see me here and ask about it. I'm quite happy to tell you why. We'll call this colour. Yeah. Again, GLM Vec4. What we're going to do is we're just going to set all of these to 0.0f, and then we're going to choose some colours in a minute. And 1.0f at the end. We'll want 4 colours, one for each of our vertices. I'll take the last comma off. You can leave the last comma on if you want. It's not illegal. Doesn't matter. Most people do. It just doesn't make sense to me. Alright, so we're going to choose 4 colours. Let's choose red, green, and blue. And the last colour we can choose is... we'll have grey. Half white is grey. Right, I'm happy with that. Next, we are going to need int. Yeah. Do we have a GL int? We do. Do we have a GLU int? We do. Right, I'm going to use that then. I'm going to do it properly for once. I'm going to call this index. You'll see why in a minute. Right. Index tells us which position to draw, or vertex to draw. So we'll start at the top with the 0 vertex. Each one of these colours, by the way, will automatically match up with each one of these vertices. You don't need to worry about that. So that's for vert 0, 1, 2 and 3, vert 1, 2 and 3. I should actually put it in. 1. They just match up. Sorry, that matches up with 0. Dar. We should do it properly. 2 and 3. So that's just notes. These are just notes. They don't tell the computer to do anything. They're just notes for me to remember. That those match up. That colour there matches up with that number there, and that one matches up with that one. And OpenGL will do that for us. We don't have to worry about it. So start in the top left. Top left. Bottom left. Bottom right. And top right. Here. So we'll start at top left. We'll go down to bottom left. And then we'll go to bottom right. OpenGL is going to take that as a triangle, and we're going to ask it to use triangles. So that's our first triangle. So we're on bottom right now, are we? So the second triangle is going to be top left to bottom right to top right. Doesn't really matter how you, as long as you set them up as counterclockwise and you do the two separate triangles, you're okay. Why are we using an index? Because we are duplicating the zeroth vertex and the second vertex are duplicated. 1 and 3 are only used once. So bottom left and top right are only used once. What the heck was that? Absolutely no idea. Must be inline. Right, so we've got an index. What can we do? Well, if I remember rightly, we can make a vertex array object, which is a glint. And we're just going to call it VAO. And that's going to be GL gen vertex arrays. It returns void star. All right, that's good. It'll just want the address of VAO. No? Is incompatible with a GL size I. Don't tell me I've forgotten how to do this rubbish. Now what's it complain about? Too few arguments in function call. Really? Vertex arrays. Not having a good day, am I? I want the loader. Well, to be doing all of those. Those are your drawings. API. Data loader. Data loader. Sounds good. Yeah, this does. Right, so how do we create a VAO? It is a glue int. Are you joking me? You just want a 1? So I was thinking right. Thank you. GL. It's a glue int and it's VAO. Yeah, we may as well keep the same thing. ID. And it's not equal to, you just generate these, don't you? Yeah. I was right. GL gen vertex array. Thank you. 1, comma, and VAO ID. Thank you. Go away. Stop squiggling at me. Alright, thank you. Right, that's our first instruction. Let's do that properly now. Right, what should we do next? Bind it. GL bind. Jesus, I can't even remember the instructions. What's wrong with me? GL bind vertex array, yeah. It's just that nothing comes up like that. GL bind vertex array, there it is. And that's just VAO ID goes in there. There we go. Now, we've bound the vertex array. At this point, whatever we do next is recorded by OpenGL. It's like a macro system. Think of a restaurant shopping list. So, what we're going to do is we are first of all going to create our index buffer, shall we? Yeah. Index buffer glue int. I'm going to use, although we could use glue short. Nope, glue int will do. And this is going to be our index buffer. And that's a capital L. Never forget that it's a capital L. Right. So GL gen buffer. That's the command. I'm guessing it's, it comes up properly now. 1, comma, at the address of index buffer. There we go. That's the correct command. magic. Once we've generated the buffer, we need to bind it so that we can take an action upon that buffer. So GL bind buffer. There's something going that says I'm wrong. It's a GL element array buffer. That one. Comma. And just the buffer itself, so it's index buffer. Index buffer. That's correct. Once we have bound it, we can then send our data to that buffer. Is that GL buffer data? Luckily we have something here that we can look at. That's bind indices, isn't it? GL buffer data, yes it is. Yeah, so we're looking good so far. There it is, that one. And it's GL element array buffer, comma, GL size IPTR size. Then it wants the data and then it wants the usage. So it needs to know the size of the data, but that's in bytes. So we're looking at the size of index multiplied by the size of type gluint. Next we are on to the data itself, const void star data. Well, that's just the index, isn't it? Comma. Or is it? No, it's not. It's looking for the address of the data, which is actually at index 0. That's what it wants, the start of the data. And the usage is going to be GL static draw. Now, there's something wrong here, so... Oh, no, it says I'm right. Am I? Size of data. Data. What did we pass the size of data in as? Where's size of data in here? Size of indices. So we got it in as the size of... No, it's the number of indices then. I'm wrong, it's not in bytes. So we'll take that bit off. Does it tell me what it is? 6. 6. It should be 6. That number should work out to be 6. We hope. Right, so we've completed that, haven't we? That's our VAO. I'm not storing it. Indices. Buffer's done. That's done. Next, we can go on to the attributes. These are a bit different, so I might refer back to this. Okay, we have 2 attributes. The first attribute we're going to have as the vertex. The second attribute we're going to have as the colour. So it's going to be attribute 0. And that's going to be vertices. There we go. Just put a marker in that, so I know which attribute I'm on. It's roughly the same as index buffer, isn't it? So it's just going to be GL uint, and this time we're going to have our vertex buffer. Bring this up the screen a bit now. GL gen buffers. It's going to be 1, comma, the address of vertex buffer. So we're up to that. Now we have to bind it so we can use it. Bind buffer. Yeah, we need to target, don't we? Target is GL array buffer. Vertex array. No, I don't put all of these into memory. GL array buffer. Okay, that'll do. And that will be vertex buffer. Right, so now we've got it bound, we can actually access it. May as well do the same as before and just put the data in, but there's other stuff to do on this. Buffer, GL buffer data. Slightly different, but not too different, I guess. It's going to be a GL array buffer. Size of vertex buffer. This is probably wrong, but hey ho. We'll need the start position. Yeah, so that's and vertex buffer 0 is its start position, and usage GL static draw. That'll do. That should match up with what we know. Yeah, I've pre-calculated the size of data, that's all. Alright. GL attribute pointer next. GL vertex attribute pointer. Okay. Let's see if I can work one of these into here. So it's GL vertex attrib pointer. That one. And this needs a bit of stuff. What do we start with? Attribute number, okay. Which is 0. That's easy enough, I can do that one. Index size. Uh, 4. Comma. Type. Floats. So it's 4 floats. Oh no. No, just give us float, thank you. Normalized false. We don't want to normalize them, thank you very much. Stride, none. We haven't missed or skipped, we're not skipping any. And const void star pointer. I'll give you a null pointer. See if it'll accept that. Yep. Means that null pointer just means start from the beginning. Right, I'm happy with that. Is that roughly what I would have put before? Remember, this is a completely different program, does the variables differently. Items per data, yeah, that's 4. A GL float, GL false, 0 and a null pointer. Fantastic. That's it. But it's not it. There's something missing there. There's a command missing in the previous version. I think it's GL enable vertex attrib or something like that. Shall we try? GL enable vertex attrib array. It's either array attrib or attrib array. Which one do I want? I want the attrib array. 0. That's all it takes. That's the one that's missing. Alright. So we now have our vertices. We can now go on to attribute 1. Let's set up the renderer. I'm just going to take time out to set up the renderer. Just so I know I haven't done it. So down here we clear the colour. We would then enable the VAO. That's just a draw elements call. Alright, that's fine. So I must have put it in the renderer itself. Oh, where did I put it? I've got prepare, start, load the light, render, and stop. Prepare. We're not exactly using OpenGL in here, are we? Where's the OpenGL being done? That's a matrix, camera, texture. Prepare instance. Just sends the matrices to the shader. Yeah, that's fine. Draw entity render. Okay, for each entity in the batch, prepare the instance and render. It's GL bind vertex array, VAOID. It's that one. We just bind it. GL enable vertex attrib array. That's the one that I've just added. This is it. GL enable vertex attrib array. You don't need it in here. You can put it here. It gets recorded by the VAO. So you don't actually need it at this point in the program. That's the texture stuff. Okay. So it's just bind the vertex array and GL draw elements. GL bind vertex array VAO ID and then we come to the fun one that usually crashes the whole program. This is the whole of the rendering, by the way. You clear the color, you load up the VAO for whatever model you want, or item, OpenGL item you want, and then you just draw it. Draw elements only accepts triangles. It does not accept quads, which is a bugger, because quite a few models have, well, you can use quads in modern day, but I don't know why GL draw elements hasn't been altered for that. But it hasn't, as I found out to my cost and had to rewrite a whole program because of it. GL draw arrays does, if you draw arrays, you're not using the index system. You're just using straight data, and that means you have to repeat a lot of data because you're not indexing it. So instead of doing that, we're going to use elements. There we go, it's that one. And this will start with GL triangles as usual, because it's the only thing it can do, so I don't know why it asks for it. So that's a GLenum mode. The size I count is the size of index. Index. Comma. Type is a GL U int unsigned. Unsigned. Yeah. Unsigned. We've used ints. So it's that one. Const void start indices. That's a null pointer. That's how far into the buffer do you want to start. So I'm going to give you a null pointer for that. Okay. And then you swap buffers. Is that roughly what I did before? Let's have a look. Yeah, null pointer. GL triangles. Get index count. Unsigned int. Null pointer. Okay. At least we're agreeing with each other on a lot of the commands. That's good. So at this point, I just want to do a quick test of the sandbox. For an array subscript, I can't use a glue int for arrays on 179. Okay, fair enough. We won't. Simple. All right. Sandbox. Ooh. I saw red. Vertex array buffer. Ah. 179. Hold on a minute. Is it complaining about me using OpenGL? Never had this before. One, 2, 6. No, it's just on 179. On the vertex buffer. What? Pointer to object type. It's meaning I can't put that 0 there. That's a pointer to an object type. But it doesn't like it because it's not the right one, is it? Const void. Right, so it's vertex buffer itself that's given us a problem. It's actually int. Oh. No. I don't know why it's having that problem there. And this has to be a pointer to the first object. There's nothing I can do about that. It's an array. Alright. That's wrong. But it says it's right. Stupidity. Has things changed over time? Okay, we've built. And we see nothing. I didn't change that to a vec4 for starters. Doesn't help. Okay, it's not going to accept vec4s, I don't think. That's a damn nuisance because I consider that wrong. What I consider wrong might not be. Right, that alters the size of the data that we are placing in there. I don't think that bothers us. I'll bother that. Okay. We see nothing. We should, by all standards, zero that out after we've used it. So that's okay. Alright, let's have a look at this initial data. Dooby-dooby-dum-dum. Looks okay to me. Attribute 0. Vertex buffer. Yeah, I'm not overly certain of these size of variables, whether they're supposed to be bite-sized or not. I think they are. Oh, that went well. Let's try that. Nah, that's not it. I think our draw call's failing, is what's happening. It shouldn't do really, but hey ho. Let's copy this lot out anyway. It's no longer the vertex buffer that we're going to be using here. This will be the colour. 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 Didn't go well. Try again. Thank you. Colour. Colour. 4. Floats. Correct. Done. That should be it. Okay, we've got a problem with Vec4 colour. Unused variable vertex and colour. What? One 118. Really? That looks better. That could be the reason. I think I was calling things the wrong thing. I don't think it had anything to do with variable types at all. Right, F5 that. Good. Bad. Got nothing on screen. Well, that's a start. F5. I've already seen what the mistake is. Colours 4, index is 6, vertex is 4. That's correct. Mistakes are here. The data size of colour. Size of vertex. Alrighty. Just because a program compiles, oh, we've done it. We have a black triangle in completely the wrong place. We've drawn something in OpenGL to the screen that's absolutely pointless. That's fantastic, says Muppet. Isn't it, love? So, how do you debug this? There's the question. So, we've actually drawn something in OpenGL. That's gone from 1, 1 to 0, 0, minus 1. So everything's shifted across. No, Muppet, you're going to have to go on the floor, sorry. I can't have you up here. Come up here. Come on. Come into your bed. Come and sleep in your bed, love. I'm trying to do something, dear. Oh, you're not happy about that, are you? Because you're not feeling well. You want to crawl all over me and sneeze at me. I know. Bless him. But we have our first render. Data's rubbish, but hey ho. And it's given an interesting result. Now comes the problem with OpenGL. How on earth do you debug OpenGL? And the answer is you can't. It's impossible. Because the draw calls are going directly through to your graphics card via a third-party device driver of some kind. In my case, it's NVIDIA 440.82. That's the driver that I've got. So, let's see if this is in bytes. Actually, we'll mess with attribute 0 first. Do I still get it if I take attribute this out of the equation? This is the question. Can I switch this buffer off? Yeah, okay. Make that. There we go. So the colour buffer's not working properly is the answer. That's what I expected to see. So the colour buffer is then messing things up somehow. So let's have a look at this colour buffer. That's what we should get, by the way. Colour buffer, colour buffer, colour buffer. And there it is. There's mistake there. What we've done is we've overwritten attribute 0 with attribute 1. Easy to debug. Easy. Ooh, we're getting somewhere. We're getting somewhere that's interesting. Because it compiled. You see, I wouldn't do it normally like this. Bind the buffer, send it the data. And add a pointer. Yeah, that's it. We didn't make it active though, did we? We haven't made it active. So it's not even been enabled. No wonder it's not working. So let's enable number 1. Now I know there's something dodgy going on. Okay. First render attempt. Color not working. No worries, we're in a debug mode. I'm not using a depth buffer on purpose. That's correct. That's all correct. I'd love to find out what the FPS is on this thing. Oh, it's 60. We've got We've got VSync enabled. He says try not to choke. somebody watching this will absolutely know what I've done wrong. So we've drawn it properly. We've got our vertex positions in the correct place now. They are drawing on screen, but our colour's not working. And I think I know why that is. I think that's because we need a shader. If I remember rightly. Because the colour, I've just sent it over on 1, and our graphics card doesn't know what to do with it. It's got no idea what to do with it. So this requires a shader, is my answer. Because we're generating one buffer, called the colour buffer. We bind the colour buffer so we can take operations on it. We send it data. Now we know that's all correct. We then give it an attrib pointer 1. And just a magic number pulled out of the air. I could put 2, 3, 4, 5. As long as it's not 0, we're fine. But I don't know what that is, or should be. And neither does our graphics card. So if I don't know, how the hell do we expect our graphics card to know? And that's my answer. So our program is working. Wow. Does that mean we should write some shaders? Well, we'll have to if we want a coloured box on screen. Let's write some shaders then. Now, for obvious reasons, this I don't like here. So let's have a test. A test box. Our test graphics. Okay. Let's get this out of here. I like what we've done. I think it's right. I think we've corrected all the silly bits because it's forced me to. I like everything there. That's the only tricky bit there that you have to watch out for, because I do believe it's in bytes. GL buffer data. Thank you. GL buffer data. Target size data specifies a pointer to the data that will be copied into the data store for initialization, or null if no data is to be copied. Now, it needs a pointer to the data. Unfortunately, we've stored it in an array because that's what OpenGL uses. And the array name is a pointer. So let's check this out a bit more. So we know that attribute 1 isn't going to work. That's fine. So let's see if this will work with just the word vertex there. And the answer is it shouldn't do. Okay. It's just the word vertex there. F5 that. It does. Because that's a pointer to the array. So I don't need to bugger around with that. Thanks, book. That simplifies the code immensely. I wonder if it'll work. Right, next thing I want to try is putting my 1.0s back on. Now I know what the reasons are for what we're getting. I'm happy. This is pure experimentation, by the way. Right, and that should give us the right sizes, the right data. Attribute 0 is now on 4. See, it's a magic number. There is a way of calculating it, but hey ho. Yeah, I'm happy now. I will write shaders for that. Now, to make sure that we are not being too dodgy with this, cd projects sandbox sandbox build. Yeah, we have a make file. Okay, which means it should rebuild everything. It did rebuild everything, and yeah, we win. We win big time. Thank you. Thank you, OpenGL. Right, refactor time. This is no good in here. Okay. It has to return a VAO. Otherwise, we can't use this. The only thing we're using out of all of that code is the size of index, damn, and a VAO ID. Bugger. We would need a struct. Well, we're going to need a struct anyway. At some point, so let's see, we're allowed them. Struct. Actually, can't put it here. I'm going to have to put it up here. Struct. To be safe. Test. Call it a square. There's a reason I'm doing it like that. We're not going to be inputting anything. It's going to have a VAOID. What do we want that to be? Gluint. Ah. Can we just not have... Yeah, well, I think we can have a gluint here. Can we? Yeah, alright then. And what else did we need? We need index size. Which... What do we make it into? Oh, we didn't make it into anything. What do they want it as? For... It's an int. It's an int. Stuff it. I'll take it as an int. GL int. Yeah. And we'll just call it index. No, we won't. Num indices. Okay. What's wrong with that? Oh, it's not a comma then. There you go. Okay. And we can return now a test square. I'm just wondering whether to make that a type or not. No, just leave it as struct. Right, what's the function going to be called? Our function is going to be called test square is our return value. Function name. Test data. Don't know what I want in there. Don't think I want anything in there. Copy it. Right, we can now put some test data in. God, there's a lot of it. If you notice, I haven't removed the attribute one, even though I spelt it wrong. Huh. So there. Actually, no, that's where I want it to go. Okay. And we'll just make a variable called a test square data. Come down to the bottom and we'll do data dot num indices equals size of indices. Yeah. And data dot VAO ID equals VAO ID. Return data. Done. We got any red markers? Yes, we have. V test square test data equals test data. So we've now got test data. Yep, that's okay. This is now test data dot num indices. Any other horrible thingies? Nope. There you go, works. That's refactored. So now we have all of our test data down here. Interesting. I'm going to have to stop doing that with these. I'm sorry to say. It's starting to bother me. There we go. Now it doesn't bother me as much. Okay. We now have a test square that shows you how you can start putting towards, starting to make models as such, as we will see in a bit. Our main entry point hasn't So program function declarations. Okay. And these are program structures. Okay. Okay, that's all that done. Functions, main event loop, blah, 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 blah. That's now the main event loop. That looks good. Test data. Attribute 0 and badly spelt attribute 1. Okay. Lovely. So I now believe that our test data is complete. I now think that this bit is complete, nearly. And I know that bit's complete. We're never going to touch that again. Right, so that's our whole program. That's all we've got. We have a run and a test, some test data, which is always good to have. What we need to start thinking about now is our next problem. Color doesn't work because we need shaders. So draw a color square on the screen to represent the user. Color does not work as we need a shader. Let's make a shader. Okay. That's where we're up to. All right. Now we do have GLM as well, so we've got everything working. We've got vectors. We have vector math. How the hell it works, I don't know yet, but we'll work it out as we get to it. And we do have it all working. Yeah. I'm quite happy with that. I know that that is rendering. Come over here, you. Just let it render for a bit. Once I work out what I want here. Alright, okay. Alright, this is me it's a thinking session because now we're talking about shaders. Shaders are not complicated. It's how you go about making them that is. Do we only want to use one shader in our program? Do we want to be able to use multiple shaders in our program? Do we want to specify the shader that we want to use for each thing that we draw in our program? Shaders are a huge, massive industry upon themselves. In fact, there are people and places and companies out there that specialise in shaders only and compute shaders as well, which I have been looking into. Not really bothered about them at the moment. I don't think they're going to be needed. I think our CPU for a game will be fast enough without having to use the GPU to compute everything as well. Even though it would be faster. Could be interesting though. It's a thought. Now, let's see, 38 degrees C. Oh, so we have gone up 1 degree C on my graphics card. Oh no. Yep. No. Yep. No. Room temperature is 37 degrees C. Yeah. Well, inside that computer, its temperature is 37 degrees C. That's how hot it is cooking in there. So it's doing a little bit of work now. Minute bit of work. And it is taking in our colour data, it's just discarding it. That's interesting. We haven't exactly gained much temperature yet. Okay. Things are checking out to be good. And I mean real good. C is a very good programming language. It doesn't overtax your machine. It's not like C++ where it all goes absolutely haywire and can impact the performance of your machine. Because C++ grows exponentially. It's a huge growth index on it. To get this far in C++, we would already be over 1 megabyte of code, a code base. That's with debug though. Without debug, it'd probably be about 256 to 350k, which is still a lot, in my opinion. But my opinion doesn't matter. People out there seem to be happy with that. I'm not. If you're on Windows, it'll all be smaller because the Windows runtime actually has the C runtime inside it, so you don't have to compile the C runtime inside of your binary. Whereas here we have done. Everything's static, everything's in the program, all the code is in the program. It's self-sufficient. I think that's the way of putting it. Right. Now we know all that rubbish. Sandbox. Let's have a new folder. I've just had a thought. I saw a failure there. It wasn't on that page. These are all the symbols that are held inside of the project. Shows you how much garbage we are taking on by doing debugging. Okay, so it wasn't on that page. There's no failure there. That's legal. I can call it anything I want. Yeah. I'll go with that. Pre-launch task built out, terminated with Xcode 2. Build sandbox, okay. Cool. Failure to find sandbox.cpp. Oh, that's right. Helps you spell it right. Oops. Where are we? Come back to me. Come back to my keyboard. Thank you. Fine. Sandbox instead of main.cpp, because I prefer it that way. So it's deleted main and added sandbox. Yes, thank you. As it should be. Good. Right, I was thinking about this load of rubbish, wasn't I? Let's make a shader. Right, so under resources, I'll need a new folder. G L S L. That's the language it's written in. Graphics library shader language. Okay. Alright, we'll only use vertex and fragment shaders then. Decided on that. Call them anything I want, really. Alright. My God. Well, I think this is about as far as I really want to be going today. I want to start on shaders probably Tuesday. I think we have done... We have actually not completed though, have we? No, I think we'll start on shaders on Tuesday. I think that's a better idea, otherwise I'm going to get absolutely brain dead. What we have at the moment is very good. For a test code, this is looking quite clean. There we go. It's all split down. It's looking good. The top of the screen tells us what we have. Excellent. We do have the text file utilities at hand. Yeah. Good result for today. That's as far as I'm going. So, in the meantime, if you want to write your own shaders, please feel free. Go ahead. Otherwise, I will start shaders on a Tuesday. Take care, stay safe, and enjoy. Now, where's that stop button? Where's it? Where have you hidden the stop button, Muppet? It's over here. Okay.